Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving headfirst into the wonderfully weird world of generalized LR parsing. It's all about parsing any context-free grammar, no ifs, ands, or buts. Exciting, right?
Absolutely. But I'm a bit rusty on my LR parsing basics. Is this going to be a total brain melt?
Nah, we'll keep it breezy. Think of it like this. Regular LR parsing is like trying to fit a square peg into a square hole. Sometimes it works perfectly. Other times, not so much. GLR parsing? That's like having a super flexible, shape-shifting peg that can mold itself to any hole.
Okay, I see. So the problem with standard LR parsing is that it struggles with certain grammars, right? It gets stuck in conflicts.
Exactly. You end up with these nasty shift-reduce conflicts, where the parser doesn't know whether to shift the next input symbol onto the stack or reduce a production rule. It's a real headache. And readability suffers.
So GLR solves this by doing everything at once? Parallel universes of parsing?
Essentially, it explores all possible parsing paths simultaneously. It's like having multiple parser instances working in parallel, sharing resources to avoid an exponential explosion of work. Clever, huh?
I'm following. Mostly. So how does it handle this parallel processing? Does it use, like, threads or something?
It uses a clever tree-based data structure, a graph-structured stack, GSS, to share common parsing states. Imagine a tree where branches represent different parsing paths. It's all about efficient state sharing to save both memory and processing time.
A tree-based data structure? Sounds elegant. But what about hidden left and right recursion? I've heard those are particularly nasty.
Oh, they are. Hidden left recursion creates cycles in the GSS, which can lead to infinite loops if you're not careful. Hidden right recursion? That's where things get really tricky. The basic GLR algorithm can just give up.
Oh dear. So what's the solution?
Enter Right-Nulled GLR, RNGLR. It cleverly short-circuits right-nulled rules where the right-hand side can be empty. This avoids some of the infinite loop problems, but it introduces new reduce conflicts.
So it's a trade-off. Fewer infinite loops, more conflicts. Sounds like a classic computer science problem.
Precisely. The article discusses techniques to resolve these conflicts, often by prioritizing earlier reductions. It's all about finding the right balance. And then there's the issue of parse forests.
Parse forests? Sounds ominous.
Not ominous, just complex. Because GLR can handle ambiguous grammars, it can produce multiple parse trees for a single input. Instead of listing them all, it creates a parse forest, a shared structure representing all possible parses. It's like a super tree of all possible interpretations.
Wow, this is a lot to take in. So what are the key takeaways here?
GLR parsing is a powerful technique for handling ambiguous grammars, but it's not without its challenges. RNGLR offers improvements, but introduces its own set of problems. The key is understanding the trade-offs and employing techniques to mitigate the complexities. It's a fascinating field, and there's still plenty of research to be done.
Definitely. Thanks for breaking this down for us. It's amazing how much complexity is hidden behind something as seemingly simple as parsing.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for listening, and we'll catch you next time with more exciting explorations of the tech world. Bye.
Bye-bye.